here is a nice geometry problem involving the square and circle. The edge of this square meets this circle at certain points, this point, okay, and crossing the square, crossing the circle at other points, which is this one and this one, so making just only one tangent. So the other side of this circle, we have this gap, which is shaded area. We call this distance from here to here, which is number 1, okay. So our goal, we are going to determine this shaded area, which is in blue, okay. In fact, there is insufficient information to determine the area of this one, but we are going to work out and extract all necessary information that we need, okay. First of all, we are going to determine the center of the circle and the square. The center of this circle, it will be here, will be at this point, okay. Let's call it 1, and the center of this square will be met with this diagonal, this one and this one. It will be around this area, will be here. So let's call it O2. Let's call this distance Z, okay. Then we have this distance, this one to this one, where the square ends. Let's call this distance X. Now let's draw the line coming from this point, passing through the center of the circle, and drawing second line passing through the center of the square, okay. So I will have the first line, another line going from the same point, passing through the center of the square, so they will share the same point. Let's call this angle alpha, okay. This angle, since we have a square here and this one passing through the center, which means this one will be pi over 4, okay. This angle will be pi over 4, because the perpendicular of this line is going to be pi over 2, which is half of it, which is pi over 4, okay. Actually, we don't need to draw the symmetry of these two triangles here, so I'm going to leave this one for later. Now the next thing up, let's determine the radius of this circle. The radius of this circle, which is R, is going to be from this point to the end of this circle, like this, which means X plus number 1. X plus number 1. This is the radius. This X plus number 1, it will be this one as well, because this one is a radius, this one is a radius, okay. Before we calculate the area of this one, we are going to determine the R and X, okay. Let's make the kind of relationship between these distances. Let's write down the whole distance of this diagonal of this circle. So we have this 2R, which is twice the radius of this circle. So from this point to this point is representing the center of the square. The center of this the square, which is X plus Z, this distance, which is X plus Z, which means I have 2 times X plus Z, because I have this distance from here to here, and I have this distance, this one. We have equality in these 2 distances, okay, plus number 1, which is left here, okay. So if you take a look carefully, I have 2 triangles here, they share in the same angle, which is pi over 2. So I have a right triangle for 2 triangles. So I'm going to apply, I'm going to work on this triangle, which is including the red one, okay. So let's take tangent of pi over 4. Tangent of pi over 4 equals opposite, which is y, over adjacent, this one, which is X plus Z. We know tangent pi over 4, which is number 1. I get y equals X plus Z. So there is a first relationship between X, Z, and y. Let's replace X plus Z with y here. I get 2R equals 2 y plus number 1, okay. Then I'm going to work on this triangle. Let's apply the sine of alpha here. Sine of alpha equals opposite, which is y, over this distance, which is the radius of this circle, which is x plus number 1. Also, I can apply cosine of alpha, which is, it will be Jason over hypotenuse, x over x plus number 1. Let's square this one on both sides and square this one also. I will have a nice formula. We know the sine square of alpha plus cosine square of alpha equals 1. Okay, this one is telling us have sine square of alpha plus cosine square alpha equals y square plus x square over x plus number 1 quadratic square, which equals number 1. It's very known formula here. So I get here, crossing the multiplication, I get y square plus x square equals x plus number 1 quadratic square. Let's expand this one out. I get x square here plus 2 times x plus number 1. Let's cancel out x square from the left and the right side of this equation. So I will be ended with this expression, y square equals 2 times x plus number 1. Here is another relationship between y and x. So this equation is involving r and y. This equation involving y and x. So we have a kind of relationship between this one and this one. And also we have another relationship between r and x here. So I'm simply going to multiply this one by 2r here. I get 2r equals 2 times x plus number 2. Then taking this to r and plug it here, this one equals 2y plus number 1. Okay, taking this one and through it here. Then next thing up, I'm going to put this equation minus this equation. Okay, so let's call this one 1 and this 2. So I get 2 minus 1. I get here y square minus 2y minus number 1. So I'm doing this one minus this one equals this one minus this one. Okay, I get 2x plus number 1 minus 2x minus 2. Okay, so then I'm going to add number 2 on both sides here. I get y square minus 2y. If I'm adding number 2 here, I get plus number 1 equals 2x plus number 1 minus 2x minus 2 plus number 2. Okay, this plus number 1 minus 2 will be cancelled out. Then this 2x and minus 2x will be cancelled out. So I will be left. This one is very known formula, is a quadratic binomial formula, which is y minus 1 quadratic square equals number 1. So square both sides. Since they have a distance here, we don't have to worry about the negative sign. So this one is telling us y minus number 1 equals 1. In the other word, y equals 2. So we have determined the distance of y. Now it's very simple to determine other distances, x and r. Taking this value of y, insert it into this one to find x. So I get here 4 equal to x plus number 1. Equivalent x. I get here, bringing this number 1 to the left, I get 4 minus 1, which is 3. 3 over 2, which is x equals 3 over 2. Then taking the value of x and insert it here to find r. I get r equals 3 over 2 plus number 1, which equals 5 over 2. Okay, I'm going to take these 3 values at the top and continue solving this problem. Let's go ahead to calculate the area of this one, which is shaded area, which is in blue. Okay, so before we do that, I'm going to complete another 2 by symmetry, because we have a distance y here. This one will be y as well, because we have a square. This one is a center, because this line is going through the center, which means this distance equals to this one, which means the triangles that I'm going to draw here, they are congruent. So I will have the same thing here. Let's draw this line from this one point, this point. So let's do the same thing, drawing this line passing through it to this one. It's very clear here, the area of this portion equals the area of this sector minus this area of this both triangles. Okay, so let's call the area of this D as a shaded area. equals this area of this sector, let's call it C, minus the area of this both triangles, let's call it ST. We know the area of the whole circle is pi is multiplied by the radius square, okay? So, but this angle is not 2 pi, so we have this portion. We need to calculate this angle first. So let's calculate this alpha. We know tangent alpha equals this distance, which is y over x, okay? Which is alpha equals arc tangent of y over x, okay? The inverse of tangent. Let's do this one. This alpha plus this alpha, which is 2 alpha over number 2, okay, is multiplied by the radius of this one. The radius is x plus number 1. Let's write this one in terms of x to have a nice expression. Minus st, that st, the area of this triangle. We know the area of this triangle is base, which is x, is multiplied by the heights, which is y, over 2, okay? You get minus x is multiplied by y over 2. But we have 2 triangles here. We need to multiply this one by minus, multiply this one by number 2, okay? Why I divide number 2 here? Because as we know, the whole circle equals the area of the whole circle, which is s, equals pi, is multiplied by the radius r square. So we know the whole circle is taking 2 pi, which means to get this one, we have divided by number 2. It's the same thing here. This angle, it will be divided by number 2, okay? So now 2 will be cancelled out, this 2 will be cancelled out. Then I'm going to replace y with number 2 because we already found y equals 2. So I get here alpha is multiplied by x plus number 1, quadratic square, minus 2x by replacing y with number 2, okay? Then replacing this alpha with this term, I get SD equals alpha, which is arc tangent y over x, is multiplied by x plus number 1, quadratic square, minus 2x, okay? Then replacing y with number 2 as well here, and with this expression. Now calculating this area, SD, arc tangent to x, I get 2, x, it will be replaced with 3 over 2, x 3 over 2 plus number 1, quadratic square, minus 2 is multiplied by 3 over 2. But remember here we are going to transfer this one to a region, to the pi. To multiply by pi and divide by 180 degrees, okay? I get here arc tangent over 3 is multiplied by pi over 180 degrees. This one, it will have 5 over 2, which is 25 over 4 minus 3. If you calculate this one, you will have approximately 2.795, okay? So I have ended this video. Don't forget to hit the subscribe button and support the channel. Thank you for watching and enjoy the rest of your day. Thank you, bye.